The human brain is a remarkably complex organ. It gives life like the heart, yet unlike our beating, red nucleus, our brain accomplishes much more multifaceted tasks. It sends our thoughts through our body and defines our minds. It is, in all ways you look at it, our soul. It decides who and what we are. It tells you what to fear. Heck, it even makes you feel love and devotion. It gives our existence meaning. So when you look at all the complex things our brain controls on a daily basis, shock is only one word to describe your reaction. From fear to anything else, you have dozens of chemicals flowing through your being that are being directed from your brain. I might be saying this entirely due to my fascination with the human brain, but if I wasn't writing, I'd probably be a neuroscientist. You see, when you think about your parents, what do you feel? This is an honest-to-God question that I want you to ponder. Think about all the feelings that flow through you on a daily basis. You think we, humans, are unique in the facet of these emotions, but you've never stopped to contribute anything we think or feel to the brain. You never stop to think, maybe other species with this vital organ feel the same. I'm keeping this essay sheerly to the brain, so I won't be going in depth on how our genomes change, how our brain. If you want to find out more about that, stay tuned for a video on our genetics. What I'm here to talk about today is the brain and only the brain. Any chemical brought up will hold the bare necessities to understand what I'm presenting. That being said, I've read through a multitude of papers on this to give the most accurate account I can. I'm not a neuroscientist, so the things said here should be taken with a grain of salt. With all that out of the way, let's get into the video. Your brain has trillions of cells flowing through it. Whether they're neurotransmitters or neurons, even other supporting cells, you have trillions of these little microscopic things telling you what to do. These things are what are thought to be, what make you conscious. In fact, it's much like a battle royal for who gets to control our thoughts and feelings. These cells, neurotransmitters in particular, give you feelings. Dopamine, serotonin, glutamate, and norepinephrine are all neurotransmitters that control us in some facet. Take norepinephrine, for instance. It's your stress chemical that produces the fight or flight response. Granted, it is also a hormone, but that doesn't change hardly anything. It doesn't change the fact that it affects the brain. To get to that part, though, they need to travel and transmit through the brain. How do these neurotransmitters do that? They use these tiny, bubble-like compartments called vesicles to travel through the brain. Think of them as a car. They travel from place to place using these cars as their medium. You can also use this logic to think of a neuron as a house. Essentially, using their car, the neurotransmitter drives from house to house. When you think of neurons and neurotransmitters this way, you should notice that the roads are missing. How do these neurotransmitters get to these places? Synapses, also known as the conjunctions your neurotransmitters use as a road, is one of the most important parts. If they didn't exist or were damaged, you'd be stranded in the middle of the desert with no cell reception. This might cause things like autism, schizophrenia, Alzheimer's, epilepsy, and even botulinum poisoning. Now that we have the world of your brain established, we can talk about the things in the world. You have your house, car, and people. But what about a clock? How do our neurons know when to detach to work? Well, you have a multitude of molecules to give credit to that. They are our alarm clocks that make sure we wake up on time and release from the neuron. With that established, we know that there are a multitude of different chemical reactions that take place to give emotion and thought. We have just enough understanding to think more in depth into the brain. We have enough to build further. The neurotransmitters release when you gain new information about something. Take finding out you came in first place in a contest as an example. Your alarm clock, the molecules responsible for the release of neurotransmitters, goes off, waking the process of serotonin production. They take their car to work through a small nanometer-sized gap and docks at its new stop, like a bus. At split-second intervals, this process is repeated, continuing on until the neurotransmitter reaches its stop, releasing its contents into the synapse gap. This is what changes our mood and thoughts, but what happens to the car when it's finished? It gets recycled before it eventually falls to wear and tear, having to be replaced. If the cells fail one of these tasks and the neurotransmitters don't get to work, botulinum is only one of the problems that occur, like said above. If botulinum does appear, it will attack proteins related to the release of the neurotransmitter. This eventually leads to a fatal form of food poisoning that is known by the name botulism. Botulinum cuts the proteins in two, stopping vesicles from being able to release their passengers. This eventually leads to paralysis. That's not to say that neurotransmitter release problems aren't attributed to other psychiatric disorders. To know just how detrimental this is, scientists genetically engineered mice to lack any particular synapses release proteins, and the mice require a significant amount of time compared to people with normal synapses release proteins. Eventually, scientists also found that the lack of this chemical is related to schizophrenia. Keeping it on the topic of mental disorders, ADHD and depression are both attributed with either a lack or too much of certain neurotransmitters. Norepinephrine is only one such neurotransmitter. Too little of it, you could be diagnosed with ADHD or depression. This revelation isn't super ironic, considering it's a stress-responsive chemical attributed to our fight-or-flight response. With this being said, let's move past neurotransmitters and into a larger scope, the brain itself. Every piece of information and sense is processed by the brain, with it being signaled to the rest of the body. Here, the body sends signals back to the brain, creating an infinite loop of signal sending. Think about shooting a text back and forth between you and a friend. Difficult, right? Now imagine all the signals sent to every neuron each second. The sheer magnitude of the information being processed here is baffling. This is why people often contribute our brains to the likes of supercomputers. Not only are they able to cause thought, brains send these signals every millisecond billions of times. The scope of this is unimaginable. The thought of sending one message every second is already out of this world for me, yet the brain can do it trillions of times a second, and that's with the knowledge that this supercomputer only weighs 1.5 kilograms. That's insane. It's like saying a computer with 100 times the processing power is only twice the weight of your phone. The brain has 6 main sections: the cerebrum, the diencephalon, including the thalamus, hypothalamus, and pituitary gland, the brainstem, including the midbrain, pons and medulla, and the cerebellum. The cerebrum is the one in charge of your motor functions, processing sensory information, conscious and unconscious actions and feelings, speech, hearing, intelligence, and memory. The left hemisphere of the cerebrum controls the right side of your body, while the right hemisphere does the inverse. What is commonly known as the right hemisphere of your cerebrum controls spatial thinking and imagery. Think about where your elbows are right now. You're using the right hemisphere for exactly this. This is what people would normally refer to as the right side of the brain. That, however, doesn't exist. You don't have different sides of your brain. The left hemisphere is in charge of abstract thinking and speech and language. In fact, you're listening to this using your cerebrum. You engage it every day, every second, and it is a large help in defining you. Without it, you'd be nothing more than a rock on the road. Seeing as how this video is long enough, I won't go into the other part. This was mainly about what makes you conscious, not every part of the brain. If you'd like to see other parts of the human brain be covered, stay tuned. While it may not happen next week, I can promise it will eventually get covered in my journey to learn more about the awesomeness that is the human brain.